Hi, Bruce again, and welcome to my Rocky Mountain lab. And I'm going to introduce you today to a Keithley 179. Uh, this is a true RMS digital multimeter. Measures AC, DC, ohms, and amps. And we'll measure the DC voltage from 200 millivolts full scale to 1000 volts full scale. Same thing for the AC. And then for the ohms, we can read from 2000 ohms full scale to 20 megohms. Current, we can read from 200 microamps full scale to 2 amps. And we have both a low and a high ohms position, which allows us to measure resistance in circuit without triggering a semiconductor device. That's the purpose. And you can choose either low or high for that. In the high mode, I believe you run the risk of triggering your circuits. So if you're doing an in-circuit test, you might consider running at low setting, and that way your readings will be much more accurate. The unit is in startlingly nice condition. And really a beauty. Got a nice, sort of a leather green surface. It's been repainted. I used a nice almond paint on it, very similar to what it was originally. And the reason I did this was that somebody had written all over it, and it had stickers and all that kind of thing, and plus it had aged, yellowed badly. So once I got it working nicely, I figured, hey, I want it to look as nice as it works, so I've done this. And as you can see, I did a nice job of masking off all of the items that I wanted to remain. Was not able to get rid of the little magic marker that's on the bottom here, but anyway, that's on the bottom. You wouldn't see it normally anyhow. So it's in very nice condition. It's got nice, bright, large, easy to read digits. It's a 4.5 digit, meaning you're going to get up to 5 digits of display. And we're going to take it through its paces and compare it. And what we're going to compare it to is my newly calibrated HP 34401. Right now it's July 2nd, and we had this Hewlett-Packard calibrated on the 15th of May, so it's been, a little over a month ago. I've got the paperwork here to prove that the unit was calibrated, so we can compare it to that as a standard, and hopefully then you'll know that we're working properly. So we're going to take it through its paces. Bear with me, and we'll set up for volts. Okay, we've dialed in 190 millivolts from the Fluke 343 there, and we see that we're reading 190 millivolts on the HP 34401, and we also see we're reading 190 millivolts on this 179 TRMS digital. This is on our 200 millivolt range, so we're reading nearly full scale. And we're going to go up to the 2 volt scale. We see we retain the 0.1900, so 190 millivolts still. And now we're going to kick up our voltage by a factor of 10. Okay. That should put us at 1.9 volts. We're getting 1.9000 and 1.9000, so it's right on the money. Beautiful. Let's go up to the 20 volt range. We are reading 19.001 and 18.999. So 2 millivolts difference out of 20 volts. In fact, it's fluctuating a little, so 19 point possibly 0 to 1, might be 1 millivolt difference, a little over a mil. If we go up to the 200 volt range, we see 19 volts, which is what we'd expect. Let's go ahead and 200, so we want to go 190, 190. Oh, sorry. Got to kick that up. Okay, we got 190 volts DC, according to the 34401. 190.03. So 3/100ths of a volt different than the 190 volts that we got on the 34401, but 3/100ths of a volt out of 190 is a very, very low error. Let's go ahead and take a look at the 1000 volt range. 189.9. And we have 190. So we are 1/10 of a volt out of 190 in the 1000 volt range. Let's take ourselves to 500 volts. 499.99. 499.9, there it is. 499.99. Good agreement. So our DC ranges are matching very well. Let's take a look at the AC ranges. We're going to connect up to this Fluke 5200A and then we'll come right back. Okay, well, we've got the Fluke 5200A, which is an AC generator, providing our voltages, which we are reading simultaneously on this Keithley 179 and on the Hewlett-Packard 34401A. Right now we have 100 millivolts dialed in. We're reading 99.999 millivolts on the HP. We're reading 99.96 millivolts, so we're 3.03 millivolts apart. 0.03 millivolts apart. That's on the 200 millivolt scale. Going to the 2 volt scale, we have 0.1001, so, and it fluctuated there between 0 and 1, so we're somewhere between 0 and 1, which would put us within a 1/10 of a millivolt, being exactly identical to the HP. Let's go ahead and on the 2 volt scale, let us go to 1 volt. Okay, we're on 1 volt and we're fluctuating between all 9s and 1. And we're reading 1.00002 and 3. So we're in agreement basically within 4 decimal places on both. Let's go to the 20 volt scale. 1.001, 0 to 01, which would be right. Let's kick ourselves up factor of 10. And we are reading 10.000 or 9.999, somewhere flashing in between. And 10.000.9 would be right there. So well within 1 millivolt out of 10 volts on both units. Let's go to the 200 volt scale, reading 10 volts, 10.0 to 0.1. Let's go ahead and kick her up. And I am getting 99.979697, and I'm getting 99.93 on the Hewlett Packard. So we are high by maybe 30 millivolts out of 100 volts. Very small amount anyway out of 100 volts. And going to the 1000 volt scale, getting 99.7, 99.8. We are reading 99.9. So we're within 1/10 of a volt out of the 100 on this 1000 volt scale. We're going to kick ourselves up to we're pretty much at our maximum now. I can kick in another 10 volts. Best I can do. I got 109.8 versus 109.9 on the 1000 volt scale. So our AC voltage is matching very closely to the HP over the entire range. Looking good, looking very good. All right, now we've got the Keithley 179 connected up to this resistostat 2. 0.01% accuracy on every resistance in here, and I've tested it out with the HP and believe everything to be accurate. Right now we've got 1.9K dialed in. We're on the 2K range. I'm reading 1.900, I don't know, 5. It's fluctuating a little bit. Let's go to the 20K scale. We are reading 1.898, 0.999 for 1K. Let's go to 19K. Okay, we've got 18.986 as a reading. Let's go to the 200K scale. We've got 19.00 as the reading, which we got 19 on there, so that's very good. Let's try 190K. We've got 190.02. Let's go to the 2 megohm scale. We've got 189.8 for the 190 that we put in. Let's go to the 1.9. Megohm, we're reading 1.898.3. And then the 20 megohm scale, 1.898. We can go to 10 megohms. Okay, we're on 10 megohms on the 20 megohm scale. We're reading 9.993. Nine megohms, we got 8.99, 7.995, 7 megohms, we got 6.995, so we're right in there. And 0. One megohm. Okay, we've got ourselves in low ohms. We are on the 2 megohm scale. We've got 1.9 megohms dialed in. We are reading 1.90, well, 1900.1. That's 1.9 megohms with 0.001 left after. So right on the money. Going to the 20 megohm scale, it reads as 1.898. Ten megohms dialed in on a 20 megohm scale, we got 9.9934. 9.994. So looking good. All right, we've got the 179 connected up to this Keithley 225 current source, which we will use to provide the current, which will run through this meter and simultaneously run through this HP 34401, which is our standard, having been recently calibrated. And we'll see how we do. Right now we are going to be on the 200 microamp scale. That's the lowest scale. And go ahead and try 100 microamps. Okay, we have 0.1 milliamps, which is 100 microamps, showing up on the HP. And we have 100 microamps showing up on the Keithley 179. That's pretty remarkable. Let's go to the next scale. We'll turn it off. We are on the 2 milliamp scale now. And we will apply 1 milliamp. And there's 1 milliamp showing up on the HP. And we are 1.0006, so we are 0.6 microamps different between the two units out of a mil. So essentially out of 1,000 microamps, we are 0.6 microamps different. Very small amount. And let's go ahead to the next scale. This would be the 20 milliamp scale. And we would go for 10 milliamps. All right, we're 10 milliamps on the HP. And we are showing 10.001 to 2 milliamps on the Keithley 179. So we are about 1 to 2 microamps different. Yeah, about 1.5 maybe. Out of 10,000 microamps. That's pretty small difference. All right, let's go ahead and go to the 200 microamp scale, milliamp scale, excuse me. And we're going to want to go to 100 here. And we're reading 99.707 on the HP. And we are reading 99.65 on the Keithley. So we are essentially 0.05 milliamps different out of 100.
0.05 out of 100. So 0.005%, something like that. Anyway, it's within tolerance of being a calibrated device according to the charts on the Keithley. And at this point, we can't generate any more current out of this device, and we still have one level left to go, and that would be the 2000 milliamp scale, or 2 amp. And in order to do that, we're going to have to rig up something here, so bear with me. Okay, we are on the 2 amp scale. I have a power supply going through a 10 ohm 50 watt 1% resistor here, fan cooled, and I'm then running through current wise through the HP and through the Keithley. So I'm adjusting my voltage on the units so that the HP shows me 1 amp, which would be mid-scale of the 2 amp range. So there's 1.000 amps on the HP, and we're reading 999.7 right now, and we are 0.8 on the HP at the same time. So we're talking less than a milliamp difference between the two out of 1,000 milliamps. So the Keithley is doing a very good job even at this higher current. There we go. Okay, I couldn't resist, and I wanted to give you a chance to see the internals of the 179 and talk about one of the features that I think makes this a very nice unit to have on hand. First of all, let's give you a look at the inside. I'm going to go ahead and remove this plate with one hand, if I can do it. There we go. And there's your circuitry. Basically built about this LSI chip, which has most of the A to D and LED driver functions already on it, so it reduced the complexity of the circuit board. And the rest of it are buffers and signal modification units, and then all of your selector switches and ranges and everything. Power supply back here. What makes this really a particularly desirable unit to my mind is the ease with which it can be recalibrated. If we take a look at the shielding on this unit, you'll notice that there's a lot of markings on it, and if you were to read it, you'd find that what these are is all of the steps involved in recalibrating this unit. So for instance, step 1 up here in the upper corner says go to the 2 volt DC scale, apply 1.9 volts DC, and adjust the potentiometer that's inside this hole, this adjustment hole. Adjust it for 1.900. And then step 2, go to the 200 millivolt DC scale, apply 190 millivolts, and adjust for 190.00 millivolts. Using points, the arrow's pointing back to this rear-mounted pot, and you adjust that pot, trim pot, to give yourself the 190 millivolts. Step 3, you actually go back and redo this. You go to the 2 volt DC scale, apply 1.9 volts, and then adjust this pot for 1.900. Step 4, We look for step 4 here. Up down here in the corner. Find 0. You adjust for center position on this pot. And step 5, you do the course 0 adjustment. You go to the 200 kiloohm low setting. So there's a low-high switch here. And you go to ohms, 200 kiloohms. And you adjust the pot here to give you 0.0. In step 6, you adjust this front pot through this hole to give yourself another 0. So you've got all zeros there. And then so on. You go to step 7, you apply a 200 kiloohm, actually apply a 190 kiloohm source to the meter. Go to the 200 kiloohm scale, go to the high setting, and adjust the pot within this particular hole. So, it can't be simpler. It's telling you every step of the way what to do, and in really the only things you need to have, you need a DC source that's stable, that will adjust, let me see, the highest DC source on here is, I believe, 190 volts. So if you can find something that can give you up to 190 volts DC stably, then you've got everything you need to do your calibrations here. AC wise, you need at least something that goes up to, I don't know, 100 volts. Looks like step 16, I see 100 volts. And then you have to have some resistances that are trustworthy. So, I use this resistostat 2, which the resistors are 0.01%. I have a source of voltage up here, my Fluke 343, or my AC voltages from the 5200A. And then I compare them. This is the other thing. I just had this meter calibrated. I know I can trust it, so I use it as my comparison source to prove that my voltages or resistance and so on is acceptable. And you adjust the unit. Really is not difficult once you've got all of the voltages and resistances available. So anyway, wanted to be able to show you that, and that's how it was done. So there we have it, folks. We have a beautiful looking Keithley 179 in immaculate condition. We have a set of leads to go with it, and we have the user and service manual on CD, so you can keep the thing going and learn how to use it and so on. So nice stand, nice condition, nice functioning, is beautiful. We run it through all the testing and it came through in shining colors. So happy bidding, and we'll talk to you again soon.